Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in lecture 02 part example 01 part D, and here we will discuss about the detailing. This is one of the most important lecture because so many students they can't able to properly detail a beam once they design a beam. Get area of steel and number of bars. So how to properly adjust those bars in a beam section and how properly do the longitudinal detailing of the beam, it is very important. We started this example from A, B, C, D parts. So in A part we covered some portion of this example. Then in B part we covered some this case 1, while in case B, in part B we covered case 1, while in part C, right, in that we covered this case 2, but in various parts C1, C2, C3 and C4. And the results of those lectures in front of you people, that in C1 part we use the direct method to find the area of steel, and we got 3.29 square inches. Now in the C2 part we use the tabular method and find the area of steel is 3.31 square inches, while in C3 part we use the graphical method and we use area of steel is 3.31 square inches, while in C4 we use trial and error method and we find out the area of steel is 3.29. so the final value is my area of steel is 3.29 square inches. In part C1 I think so we use we find out number of bars, that how much bar will give us this amount of steel. So we find out two best selection. The first selection is number 7 bar and the second selection is at number 6 bar. This one will give us 3.52 square inches, while this one will give us 3.6 square inches. So in view of the spacing criteria, this selection is one of the best selection because it gives us around about 2.85 I think so inches clear spacing in amongst the bar, while although this one is also the best one because it is close to 3.29 square inches, but the spacing in bar is around about 1.85 I think so square inches. So we finally choose this one. Now in today's lecture you people will see that how we can provide this kind of bars in the beam cross section. But let me discuss this table. I have already discussed this table in my previous parts. Here if you people see here that if let's say if you are using number 6 bar, this table is drawn for one layer, but we are assuming 2 layers because in one layers 8 number 6 bar is not sufficient, because if you can see here, if you provide 8 number 6 bar, the minimum beam width which is needed is 17.5 inches and our beam width is 12 inches. So we can't adjust 8 number 6 bar in one layer. That's why we are using 4 number 6 bar in one layer, which need the beam width is 10.5 inches, right? So this is all about for this arrangement. If let's say if you are using the number 7 bar, this one, let's say if you are using this option, and if you want to place all the bars in one layer, so whether it is possible because we have 6 number 7 bar, so how much width is needed for this option? So here you can see number 7, so we have 6 bar and 6 bar needed 14.7 inch width, 14.7 inch, and our width of the beam is 12 inches. So that's why this option is wrong. We can't choose 6 number 7 bar in one layer. We have to place these bars in 2 layers, right? We have to place these bars. So let's say we are using 3 number 7 bar. So how much width is needed is 9 inches. So that's why the needed width is 9 inch, and in our case the beam width is 12 inches. So this arrangement, this one is okay, right? This is all about how to find the minimum width which is needed for your number of bars. Let me draw the section, the beam section. Right now you can see this is the beam section, and here you can see we have 3 bars in top and 3 bars in lower bottom, right? And remember this is the 3, this is 3 number 7, and the lower one is 3 number 7, right? Now the spacing is, I already discussed this, I think so, in part C1. So the spacing is okay. We will check this. We calculate S, then S minimum, and then S max. So watch, I think so, see part C1. Part C1, lecture 02E01 C1 part. We have calculated this, and we find out the vertical spacing is how much needed. Let me show you those. So here we have, you can see we calculated S for 6 number 7 bar. So the calculated value is 0.6, but in one layer it is not sufficient. So that's why we transfer this calculation to 2 layers. We are using here 3 bars in one layer. So in that case 2.81, that is my S, which is more than S minimum, and the final and S max is 10.31. so that's why SP is greater than S minimum, and I have already discussed this, and this is my final arrangement. You can see here 3 number 7 bar in top and 3 number 7 in bottom. Similarly, if you are using number 6 bar, so 4 number 6 bar in the top while 4 number 6 in the bottom, and it will give us the clear spacing amongst the bar is 1.75. so both arrangement is okay, because the lateral spacing in between the bars which is needed is 1.33 inches, which is less than 1.75. so we can use either this option or we can use either this option. Both option is okay, right? So this is the final cross section, and let me draw the longitudinal cross section. I have already discussed this graph, right, in my previous part. So let's say if you are using the curtailment. Now for curtailment, you can see the bar in the top will be cut off at a distance of L1/4, while this is just for simply supported edge. So that's why, and from this side it can be cut off L1/8. But in the case of simply supported beam, it is cutted down at a distance of ln/20, right? So in the case of simply support, because it is a continuous beam, right? In continuous beam the detailing is different, while in the simply supported beam the detailing is different, right? So this is my diagram, this is my supports, and make sure that this bar should enter right into the inside the wall, or inside the wall up to a distance of 6 inches. These are my top bars, which is 2 number 4 bar, just to hold the stirrup. This is my stirrup, this is number 3 at the rate of 12 inch center to center. This is assumed. Now Here you can see if we draw a cross section right here and if we draw a cross section right here, so both cross section is different. Here I'm cutting this bar at a distance of ln by 20, right? Ln by 20. So my clear span is 25 feet, right? My span is 25 feet. So this will be 25 times 12 divided by 20. It will give me 15 inches, right? And this top bar will be cut off from the face of the support. Yes, from the face of the support for a distance of ln by 4. Ln by 4, right? So 25 times 12 divided by 4, it will give me 6 feet and 3 inches. Similarly for these two options as well. Now here if we draw a cross section right in this AA, and if we draw a cross section right here BB, so at AA the cross section will be different. Here the cross section is 3 number 7 bar in the top and 3 number 7 bar in bottom, right? And here we can see 2 number 4 bar. This is section AA, but here the section will be different. At this point we have only 3 number 7 bar, because 3 number 7 bar are discontinued right here, and here we have 2 number 4 sorry, and 1 number 7, right? So here we have, this one is number 7, so 1 number 7 bar and 2 number 4 bar, and stirrup is 3 by 8 at the rate of 12 inch center to center, right? And this is all about for the curtailment of bars. And if we use the bent up bars arrangement, so in the case of the bent up bar arrangement, the detailing will be this bar will be cut off at a distance of same distance ln by 20, and this bar should be bent up to the top, right? This is, we already calculated this one. This is this bar should be bent off at a distance of ln by 7, right? Ln by 7, so ln by 7, 25 times 12 divided by 7, it will give me 3 feet 6 inches. So this is bent up to the top at a distance of, and again this is 1 number 7 bar, right? And this bar should be discontinued at a distance of ln by 20, which is 15 inches, right? And here we have, here at this location we have how much bars? Again we have 1 2 3 4 5 and 6. So here we have 3 number 7 bar, sorry, 6 number 7 bar, right? So and again we have stirrup, which is continues, this is number 3 at the rate of 12 inch center to center, and at the top we have 2 number 4 bar to hold these stirrups, and we have 12 inch bearing, right, which will be a column, right? So we have 12 inch bearing, and the support width is 12 inches, right? This is column. And this is the final detailing, right, of the bars that how you can curtail your bars. And here you can see the detailing L/7, and the bars at the top should be cut off at a distance of L1/4 from a discontinued edge. And this is all about the detailing. And inshallah, in next example, which is example 02, we will cover some different examples. See you in that lecture. Thank you for watching.